Hi, in this session we will proceed to the next chapter, that is isometric projections. And here we have to refer a problem from our auxiliary projections chapter. And here we will consider a cube resting on HP on one of its base corner in such a way that its solid diagonal is perpendicular to VP. So we have already solved that problem. First of all, we will consider that it is resting on HP like this, and here we have the solid diagonal. After that, we will consider that the solid diagonal is parallel to HP and we will draw the elevation. We will draw the corresponding plan. After that, we will tilt this plan by 90 degree to obtain this plan. After that, we will project upwards and we will obtain this final elevation. And in this elevation, the solid diagonal, that is C dash E dash, is perpendicular to VP. So since it is perpendicular to VP, it will appear as a point in the elevation, and the remaining points are like this. And we will consider this final elevation as the template for our isometric projections. If you consider this final elevation, you can see that these two edges, that is edge GF and GH, are making 30 degree inclination with respect to the XY line. This is the XY line, and this angle and this angle are making 30 degree inclination with respect to the XY line. And if you consider the length of this line, then you can see that the length G1 dash F1 dash is around 0.816 times the actual length of the cube. That means this length will be equal to, here in this case, the actual length of the cube is 50 mm. So the apparent length here, that is G1 dash F1 dash, is 0.816 times 50. That will be the apparent length of G1 dash F1 dash. And from this we can arrive to conclusions. These two edges will make 30 degree inclination with respect to XY line, and at the same time these edges will be of 0.816 times the actual dimension of the cube. And this is our base figure for the isometric projections chapter. In isometric projection, we will consider that this cube is a cubical glass cage. It is not a solid cube, but it is a cubical glass cage. Its walls are made of glass sheets, and inside this we have a empty portion, and we will tilt the glass cage in this pattern, and finally we will obtain the final elevation, and this will be the glass cage. So what is the specialty of glass cage? You can see through its walls. If you are placing something inside this glass cage, then we can see that object through the walls because its walls are transparent. And we have a glass cage, and it's the inner portion. We can place some objects inside the cage. And if you want to draw the isometric projection of an object, then we will place that object inside this glass cage. We will centrally place that particular object inside the glass cage. And after fixing the glass cage to the base, centrally fixing the object to the glass cage, we will tilt the glass cage so that its solid diagonal is perpendicular to the vertical plane. And after that, we will get the view of the object through the walls. And that view is known as the isometric projection of that particular object. Suppose that we are placing a square prism inside the glass cage. So here we will place that square prism. If you draw the vertical projector, then you will get two lines like this, and this is the top view. And in the final elevation, you will get a view like this. I'm drawing a rough sketch. And you can connect these two ends, and here we have dotted lines. This line also will be dotted lines, and this is the isometric projection of that square prism. And this square prism is centrally placed inside the glass cage. And what about the side dimensions? It will be of 0.816 times the actual dimension. And what about this angle? This angle will be 30 degree. This is 30 degree. This angle will be 30 degree, and this angle will also be 30 degree. And for drawing the isometric projection of a square prism, you have to draw two 30 degree lines like this, say like this. And after that, you can take 0.816 times the actual dimension of that prism, and you can mark this point and this point. After that, you are taking another 30 degree line. This angle is 30 degree, and you can draw another two lines in both directions. Then you can project upwards, and you can mark the height. This height, what about this height? This height will be 0.816 the actual height, and you can mark these 4 points. After that, you can connect, and you can obtain the final elevation. And we will use this concept for drawing the isometric projection of our first object. I will explain the details with the help of an example. And that is the end of this introductory lesson. Thank you.